Hello everyone, I am Dr. S. Srinivasan and I will be talking about application of coordination compounds. The first topic is estimation of nickel using DMG. Theory of estimation of nickel using DMG. Nickel is estimated as nickel dimethyl glycoxane whose brilliant red precipitate are formed by adding alcoholic solution of dimethyl glycoxane to a hot and slightly acidic solution of the nickel salt and then adding a slight excess of dilute aqueous ammonia solution. Nickel DMG is a coordinate chelate compound which is highly colored with a low degree of dissociation. The complex gets precipitated within a pH range of 5 to 9. Higher the pH, more complete the precipitation. To maintain the pH nearly to 9, the precipitation should be done in presence of ammonium chloride and ammonium hydroxide. 1. Preparation of DMG. 1 gram of DMG is dissolving in 100 ml of absolute alcohol and 1 ml of this solution is enough to precipitate 0.0025 gram of nickel. The nickel is precipitated as nickel dimethyl glycoxane by adding alcoholic a slight excess of aqueous ammonia solution. This is the nickel DMG complexes. Procedure. Take a Couche crucible or sintered crucible and heat at 110 to 120 degrees Celsius in a hot air oven for 20 to 30 minutes. Remove and cool it in a desiccator for 50 minutes. Then weigh it on an electronic balance and note the reading. Repeat this process for 2 to 3 times to obtain constant weight for crucible. The given nickel solution is made up to 100 ml in a standard measuring flask. 20 ml of the solution is pipetted out into a 250 ml beaker. About 5 ml of 1:1 ratio HCl is added and diluted to 150 ml. The solution is heated to 70 to 80 degrees Celsius and 25 ml of 1-methyl dimethyl glycoxane DMG in alcohol is added, immediately followed by dilute ammonia solution dropwise until it strongly smells of ammonia. The solution containing a precipitate is heated in a water bath for 30 minutes. The precipitate is allowed to stand for an hour. Filter the solution through a previously weighted sintered glass crucible. The precipitate is washed with cold water to free chloride. The crucible is placed in a dry 100 ml beaker and heated in the air oven at 110 to 120 degrees Celsius for 1 hour. It is cooled in a desiccator and weighted and repeat drying until constant weight is obtained. Calculation. Mass of sintered glass crucible weight is equal to W1 gram. Mass of sintered glass crucible plus nickel complexes is equal to W2 gram. Mass of dimethyl glycoxane nickel complexes equal to W2 minus W1 gram. 288.69 gram of nickel complex contain 58.69 gram of nickel. Mass of nickel in W2 minus W1 gram of complex equal to W2 minus W1 multiple to 58.69 divided by 288.69. Therefore, mass of nickel in the whole of the given solution equal to W2 minus W1 into 58.69 multiple to 5 divided by 288.69. The next topic is estimation of hardness of water using the EDTA. EDTA method is used to determine the hardness of sample water. EDTA refers to disodium salt of ethylene diamine tetraacetic acid. EDTA. Ethylene diamine tetraacetic acid, abbreviated as EDTA, is one of the suitable and widely used chelating agent, ligand. It is a hexadentate ligand which coordinates with a central metal ion through 2 nitrogen atoms and 4 oxygen atoms as shown below. Principle. It is a volumetric method based on the principle of formation of complexes. Ethylene diamine tetraacetic acid forms colorless complexes with calcium 2+ and magnesium 2+ ions present in water. Pure erythrone black tea is blue in color, and the pH range of 9. The erythrone complexes are less stable than EDTA complexes. EDTA solution is added to erythrone calcium 2 plus or magnesium 2 plus complexes. It displaces pure erythrone to form EDTA calcium 2 plus or magnesium 2 plus complexes. At the end of the point, the erythrone black tea to change the color of the solution from wine red to steel blue. Erythrone black tea magnesium 2 plus complexes plus EDTA gives EDTA magnesium 2 plus complexes plus erythrone black tea, and erythrone calcium 2 plus complexes when react with EDTA, it forms EDTA calcium 2 plus complex and erythrone black tea. Procedure: the purette is filled with a standard EDTA solution, and 50 ml of pipette is washed with distilled water and rinsed with a sample of hot water. Exactly 50 ml of hot water is pipetted out into a conical flask, and 5 ml of ammonium chloride and ammonium hydroxide buffer solution is added. A pinch of erythrone black tea indicator is added. The color of the conical flask solution changes into wine red. The water sample is titrated against the EDTA solution taken in the burette. The color changes from wine red to steel blue. This is the end point of the titration. The burette reading is noted. The titration repeated until 2 consecutive values agree. From the volume of EDTA, the hardness of sample of water is calculated. So next topic, structure of hemoglobin. All organisms require oxygen in order to survive. It is formed during photosynthesis involving biologically important redox reaction. Different types of proteins have different tendency to bind and transfer oxygen. These proteins are known as oxygen carriers. The most important 2 oxygen carriers proteins are hemoglobin and myoglobin. Each hemoglobin molecule consists of 4 subunits. Each subunit is a folded chain which consists of a protein unit. That's such as globular protein called globin, a hemigroup and histone unit. The hemi unit is a chelate of iron with a porphyrin ligand. Its molecular weight is about 65,000. The 4 polypeptide chains of hemoglobin are wound in such a manner that the molecule is spherical in shape. The iron in molecule hemoglobin is in the Fe2 plus state. It is very important one. Ion in hemoglobin molecule is in the Fe2 plus state. It is coordinated to the 4 nitrogen atom in the porphyrin group. 2 more ligand, a histidine unit and a water molecule are also coordinated to Fe2 plus. The histidine ligand is the link between the hemi group and protein unit. The whole structure complexes is octahedral in nature. The porphyrin ring is conjugated and planar. The water ligand in hemoglobin can be readily replaced by molecular oxygen to form the red-colored oxyhemoglobin, which is present in the arterial blood. The water coordinated complexes called deoxyhemoglobin is blue. As each subunit can bind on oxygen, each hemoglobin molecule can bind up to 4 oxygen molecules. In oxyhemoglobin, the Fe2 plus is in the low spin state and it is diamagnetic. The next one, the oxyhemoglobin, the Fe2 plus is in the high spin state and is paramagnetic. The role of hemoglobin in living system. When we breathe in air, oxygen of the air combines with the hemoglobin present in blood to form oxyhemoglobin. This process is known as oxygenation of hemoglobin. This takes place in the lungs, ion in the +3 oxygen state. H2O molecule present at one of the axial positions in hemoglobin is reversibly replaced by oxygen in the process. So hemoglobin that react with oxygen molecules is produce oxyhemoglobin and water molecule. Thank you.